Hi everyone, welcome to this next video. So in this one, what I'm going to do is just go through 20 questions in the style of paper one, so all non-calculator, ranging from highest common factor, lowest common multiple, you can see there, all the way through to vectors as my question 20. Varying levels of difficulty, but basically what I'd suggest you do is, as I go through each one, maybe pause it, see if you can answer it. I'll then go through it. If you're struggling with that exact style of question, what I'll do in the description, I'll put a link to the video I've made, which will go into it in a little bit more detail. And then you can use that to kind of help you go through it and then refine it a little bit more. So we'll jump straight in and we'll start looking at question one here with the highest common factor, lowest common multiple. So first thing here we're looking at doing is, there's multiple ways you could do this. You could do your 120 times tables, you could do your 150 times tables, and then find your lowest common multiple that way, or you could do factor pairs and then figure out what the highest number is that shows up in both lists. However, the way I'm going to do this is by doing a prime factor tree, breaking it down to a prime factor tree, and then using that information to put in a Venn diagram. So we're going to start with 120. We're going to split that into 12 and 10, 6 and 2, 5 and 2, 3 and 2. So I'm going to all my primes, circle all my primes, and then I'm going to do exactly the same for 150. So 150 is broken down into 15 and 10, 5 and 3, they're both primes, and 5 and 2, they're both primes. So from here, what I can now do is start to put this information into a Venn diagram. So here's my Venn diagram, and I put 150 and 120. And then basically what you're doing is playing a game of snap first of all. So what number shows up in both lists? Well, 150, there's a 2 there and there's a 2 there. So I can put a 2 in the middle. Then what I've also got is a 5 and a 5. So 5 can go in there. I've got nothing else. So in here, there's no other 2. But there is a 3. So I can use that 3 and that 3. And that goes in the middle. Then I look again. Is there any other 2s in this list? No. So therefore, whatever's left over, so the 150 has got the 5 left over there, and then the 120 has got a 2 and a 2. So that's my Venn diagram filled out. The most important thing to do is get that center bit right first. Then, to find the highest common factor, the highest common factor is just this middle bit here. So you're looking at what numbers are in the middle, and you multiply them together. So I do 2 times 5 times by 3. 2 times 5 is 10, and 10 times 3 is 30. So your highest common factor for this question would be 30. And to find the lowest common multiple, what you actually do is just multiply all the numbers in the Venn diagram. So 2 times 2 times 2 times 5 times 3 times 5. That's what I'm being asked to do. Okay, and that whole idea of getting that middle bit right means you don't have any duplicates in there that would cause that to be off. So when you actually work that out, and you could work that out, you could kind of go 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40, 40 times 3 is 120, and then 120 times by 5 is 600. Okay, and that is your lowest common multiple. So that's how I would answer a question on lowest common multiple, highest common factor, just purely because it doesn't matter what the numbers are. It means that I can actually just work it out based on any numbers. I don't have to worry too much about going really, really high in terms of doing my timetables, etc., etc. Okay, moving on to question 2 now. We're going to look at some Venn diagram stuff. So here in this question, what we're looking at is this E at the top here basically just tells you these are all the numbers that need to go in this Venn diagram. Okay, so all the numbers there, 1 to 15, 0 is not in it. And then it tells me that A are all the prime numbers. So what I would do first of all with a Venn diagram question like this is, I would look at listing all my prime numbers first of all. So 2 is my first prime number because 1 isn't a prime. 2 is my first. 3, 5, 7, 9 is not a prime. 11, 13, and then the next one would be 17, but obviously that's too high because I'm only going up to 15. Then what I would do is I'd list all my odd numbers. Well, 1, 3, 5, 7, 9, 11, 13, and 15. So by doing that, what you then want to do is similar to what we just did in the last question, is you want to play snap, you want to match up what is in both. Well, we've got a 3 in both, so 3 goes in the middle. I've got a 5 in both, so 5 goes in the middle. I've got a 7 in both, 7 goes in the middle. I've got an 11 in both, 11 goes in the middle. And I've got a 13 in both, so 13 goes in the middle. Okay, from here, what I'm then going to do is I'm going to cross off those numbers from my original list. So 3's been dealt with, 5's been dealt with, 7's been dealt with, 11's been dealt with, and 13's been dealt with. So by crossing them off from the list, it means you're not going to be accidentally putting them in again. Then you need to look at what's left over from your list. So I've got a 2 here that needs to go in A, because that's left over, it can't go anywhere else. Then I cross that off. And then I've got this 15 and this 1 that needs to go in B. So 1 and 15 can go in there. Cross that off and cross that off from the top of your list as well there. Okay, so I've dealt with all my prime numbers, I've dealt with all my odd numbers. Now what you need to think about is all the numbers that are left up here. So you've got 4, 6, 8. Oh, I've forgotten 9. So this is why we do this. So 9 should have been that one there. 9 should have gone there. So that should have been crossed off. 8, 10, 12, and 14. They're all the numbers I've got left. So those numbers need to go into the outside. So 4, 6, 8, 10, 12, and 14. And now that I've done that, I know that I have accounted for every single number that has to be in there. I also know that there's no duplicates because as I did each one, I crossed it off. Okay, so that's your Venn diagram done. It says a number is selected at random. Find the probability of A and B. Now, this means the middle section. So A and B is A intersection B. Think about it a little bit like fish and chips. If you were having fish and chips, you're having both. So it means I'm having this middle section here. So what you're basically looking at is asking me about probability. So remember, probability is a fraction, decimal, or percentage. It's asking me how many numbers are in that middle section. So 1, 2, 3, 4, 5. And then out of how many numbers are there in total? Well, we've got 1, 2, 3, 4, 5, 6, all the way up to 15. So it's 5 over 15. Or if you wanted to simplify that, you can write it as a third. Okay. So probability, remember, is a fraction, decimal, or percentage. And it's if you want to simplify it, you can, but you don't have to. Okay, so that's your Venn diagram. So moving on now to question 3, we're going to be looking here at forming and solving equations and using that information to then answer the question. So it says the area of the rectangle is equal to the area of the triangle. So first thing you've got to be thinking about, we've got an area of a triangle here, which we know is going to be base times height. Do not forget that divide by 2 part, because that's the bit that pupils will forget. The divide by 2 is really important there. So let's just work out first of all the area of the rectangle. So I'll do that times by that. So 5 multiplied by 2x plus 3 ends up giving me 10x plus 15. So that's your first thing to do. You think all I'm doing is finding the area of a rectangle, so just multiply the two sides together. Just remember it's that times that and that times that. Area of the triangle is base times height. So we're going to be doing effectively the same thing, but this time you're dividing by 2. So it's base times height divided by 2, which gives you 28x minus 70 divided by 2, which is 14x minus 35. So you could do that, or you could have halved this and then times it by that. It wouldn't matter which way around you do that. It will give you the same answer. So we just picked up a mark here because we've actually worked out the area of either one of them. But it tells me that the area of the rectangle is equal to the area of the triangle. Well, using that information, I say the area of the rectangle, which is 10x plus 15, is equal to the area of the triangle. So by writing that out, I'm picking up another mark because I'm forming an equation. Now it's a case of rearranging this, and however you rearrange is up to you. But I like to move things over the equal sign. Whenever you've got an x on both sides of the equal sign, make sure you move the smaller x. So I'm moving the 10x over that way, which means the minus 35 is going to go that way. So we end up having 15 plus 35, because the 35's come over, is equal to 14x plus 10x. Minus 10x. Okay, because the 10x that is a positive 10x. When I move it over, it becomes a minus 10x. So that gives me 50 is equal to 4x, and then divide by 4, so 12.5 is equal to x. So we just picked up another mark there for finding x is 12.5. And now we'll read the question. It says find the perimeter of the rectangle. So all I do is I go in here and I change this for 12.5. So I'm doing 2 times by 12.5 and then plus 3. That will give me the top length. Well, 2 times 12.5 is 25 plus 3 is 28. So that becomes 28. I know that this would be 28 and I know this would be 5. Okay, obviously this is not drawn to scale because that is the longer side. So I probably should have done it the other way around, but the process for the question is the same. Add all that together. So then you're saying 28 plus 28 plus 5 plus 5 gives you a total of 66 centimeters. And that is your perimeter for this shape. Okay, so that's your question 3 done. Hopefully that helps you. Question 4, we're now moving on to plotting the equation of a line. Okay, so from here it very clearly says do not use a table of values. So when I say a table of values, we're looking at something like this. So it would be -3, -2, -1, 0, 1, 2, 3. So we're not going to use a table of values to do this now. What we're going to use is just this information here. And by using that information here, we're just going to plot the points. So remember that we want it in the form of y equals mx plus c, but in this case it's y equals c minus mx. So the c part will be your y-intercept. That's the bit that's not attached to x. So in this question, this is your y-intercept. Okay, you're looking for the part that is not attached to the x, which is not next to the x. In this case, it's 7. So on my graph, I go to my y-axis. Remember that your y-axis is that one, your x-axis is that one. You go to 7, and then you put a cross at 7. So you put a cross on where the y-intercept is. Remember, it's not the bit that's attached to the x, that's the y-intercept. Now, the next part is your gradient. This is my gradient. Now, what that means is, it's how steep the line is. So in this case, the gradient is -1. That's a minus x. So I go across 1 square. So to do this without a table of values, what you do is you go from that y-intercept, you go across 1. Now, that's not 1 in this case. Be really careful. Read your scale carefully. You go across 1, which is to there. And then, because my gradient's -1, I go down 1. So I then put a point there. I do the same thing again. I go across 1, down 1, across 1, down 1. So they are my points for that line. Now I've run out of space here. So what I can now do is go across the other way. And because I'm now going left, I go up. So I go across 1, up 1, across 1, up 1, across 1, up 1. So this would be my line plotted for that graph. So that is a line y equals 7 minus x. Or you could write that as y equals minus x plus 7. Now let me give you a different example to make it a bit clearer. If it was something like y equals 2x plus 3. If that was my equation, I'd go to 3 on my y-axis. I'd go across 1, so that's your y-intercept. And this is your gradient. So my gradient is now 2. So I'd go across 1, and this, so always across 1. And this time, because my gradient is plus 2, I go up 2. So I then put my point here, across 1, up 2, across 1, up 2. Run out of space there, so I go the other way. So this time, I go back 1, down 2, back 1, down 2, back 1, down 2. So that would be my line for y equals 2x plus 3. Okay, so that's how you plot a graph without using the table of values. Okay, right, moving on to question 5 now. We're going to look, question 5 here is about error intervals. So we're going to talk about this one now. So it says a number's been rounded to 1 decimal place. The resulting answer is 5.7. Write the error interval for x. So in this one, we're not too worried about the fact it's truncated or anything like that. This is just your basic error intervals. So what you do is you say, imagine that you live at 5.7. So the next house would be 5.8. That's where I live next. And the previous house would be 5.6. What you want to do is put a fence up in the middle. So therefore that would be 5.65. And that would be 5.75. And this is your lower bound. This is your upper bound. 5.65 goes there. 5.75 goes there. The only time that gets a little bit harder is if you would be looking at if it says that it's truncated or that the number on the calculator display begins with. And if you check the video for that, I go into that in a little bit more detail about bounds for you so you can get your head around that. Okay, question 6. So we're looking at surds here. Now, straight away when I'm looking at this, it says show that root 8 plus 7 can be written in this form. This is basically saying to me, if you've got a surd at the bottom of the fraction, you need to rationalise. Okay. Now, to pick up 1 mark in this question, all you need to do is multiply it by the opposite of the bottom. So at the moment, we've got root 8 plus 7 over root 2 plus 4. I need to multiply this whole fraction by the opposite of this. And the opposite of that is root 2 minus 4. Okay. Now, the reason that works is imagine you had something like this. If you had x plus 3 and x minus 3, when you multiply that together, you get x squared minus 3x plus 3x minus 9. So at this point here, what happens is these bits cancel out. Minus 3 plus 3 is 0. So you're left with just x squared minus 9. So if you're imagining there that the x part is the surd, we've got rid of it. Okay? So the concept of what we're doing here is exactly the same. So let me show you now. So we're basically saying root 8 plus 7 multiplied by root 2 minus 4, and then over root 2 plus 4 brackets root 2 minus 4. So if we use that mu method to expand the bottom, well, root 2 times root 2 is root 4. So root 2 times root 2 is root 4, which is just 2. So I can write that as 2. Root 2 times minus 4 is minus 4 root 2. 4 times root 2 is plus 4 root 2, and hopefully you can see there what's happened. And then plus 4 times minus 4 is minus 16. Then we do the same for the top. So we're doing root 8 times root 2, which is root 16. Square root of 16 is 4, so that just becomes 4. Then we're doing root 8 times minus 4, which is minus 4 root 8. And then I've got to do 7 times root 2, which is plus 7 root 2. And then 7 times minus 4, which is minus 28. So the bottom, at this point here, the bottom now cancels out. So minus 4 root 2 plus 4 root 2 disappears. So we're left with 2 minus 16, which gives me minus 14. So I end up with a negative 14 at the bottom because this is cancelled out. Then we need to tidy this top up. Well, we can work with the numbers. 4 minus 28 would give me minus 24 straight away. But I've got a problem here in the fact that this is a root 8 and this is a root 2. I'm just going to zoom in so you can see it. If I've got a root 8 and a root 2, they can't be combined at the moment. So I need to simplify this root 8. Now root 8 simplifies to 4 times 2. Square root the 4, bring it on the outside, becomes 2 root 2. So root 8 actually becomes 2 root 2. However, what we've already got is this minus 4 on the outside. So you need to then do minus 4 times the 2 that you're bringing out. So that becomes minus 8 root 2. Okay? And then you're adding the 7 root 2. So minus 8 root 2 plus 7 root 2 is very simply minus 1 root 2, or we could say just minus root 2. Okay? So you can see now we're looking quite similar to this, but there's a fundamental problem here. This says a plus root 2 over b, but we've got a negative a, we've got a negative root 2, and we've got a negative here. So what I now need to do is basically multiply all of this by minus 1. By multiplying it all by minus 1, it becomes 24 plus root 2 over 14. Okay, so what I've basically just done is switched all the signs there. So that looks like the correct format. A is 24 and B would be 14. So I know I've answered it correctly. Okay, again, if you're a little bit unsure on the whole rationalising process, definitely worth watching the video I've done on that because I've gone into it in a little bit more detail so you can get your head around that. Okay, so question 7 here, what we're looking at is changing the subject of a formula. Now, the reason this is slightly more complicated than would be on the higher paper is because what we're talking about here is the fact that there's two different values of x. and I'll show you why. So we're making x a subject. So the first thing you should do is when you get a question like this, look at it and think, right, okay, there's my x, I've got an xy, but I've also got an x on its own here, which means that and that can't go together because one's an xy and one's an x. So that's why this is a slightly harder process of changing the subject of a formula, which will involve factorising. So the first thing I'm going to go through my process as normal is I need to get rid of this q. So I'm going to take it over here, and it's going to become a times by q. So therefore it becomes xy plus b is equal to q, and I'm multiplying q by x plus 2. Expand that out, so I end up with xy plus b is equal to qx plus 2q. Okay, so that's my first process. I need to make it so it's a linear, so it's a straight line, there's no fractions involved, and now I go through the process of getting x's on one side, numbers on the other. So here, my x goes across that way. The reason I'm moving that is because I need my x's together, because x is what I'm making the subject. If that x is going that way, the plus b has to go the other way, okay? So that means I've got xy, staying where it is, minus now qx, because this is going this way, and at the moment it's a positive qx, so when I move it over it becomes a negative qx. Then the plus b is going this way, and it becomes a minus b. So 2q, staying where it is, minus b. So I've got all my x's on one side, everything else on the other side. Now at this point, the problem I've got is that I can't get the x on its own unless I factorise. So at this point is when you factorise. So from here, I factorise out the x because I need to get x on its own. So x goes on the outside of my brackets. How do I get x to xy? Multiply it by y. And how do I get x to minus qx and multiply it by q? Then that is 2q minus b. Final step is now I need to get this on its own. Well, x on the outside with that in the brackets means multiplied by, so all of this goes the other way, and it becomes x is equal to 2q minus b, all divided by y minus q. Okay, so a little bit harder to do, a little bit more complicated than just normally rearranging an equation, but just remember, when there are two different values of x that can't be put together, that's when you have to go through this process and then factorise out the x. Okay? Okay, moving on to question 8, we're going to look at some laws of indices stuff here now. So, laws of indices, again, definitely worth writing down the key things in a notebook, and then before you go into the exam, it can be that last little bit of revision that you just refresh it in your mind. If it's a negative indice, so effectively we can put 64 over 1. To get rid of the negative part, we just flip that upside down, so it now becomes 1 over 64. Okay, so think about it like that to start with, and then it stays as to the power of 2/3. So you can think about it like that, and that gets rid of that negative part, so it eliminates that complication straight away. From here, it's now a fractional indice, so it's a negative fractional, so we deal with the negative part first by flipping it upside down, and the fractional part, whatever the denominator is, so it stays as 1 over, whatever the denominator is, we put a root sign, and then we put the 64 underneath it. The denominator falls to the outside, so it becomes cube root, and you do the cube root of 64, and then whatever you get, you square that. So it becomes 1 over, or the cube root of 64, what times by itself 3 times gives you 64 is 4, and then you have to square that, so it becomes 1 over 16 would be your final answer for this one. Okay, so as I say, definitely worth watching my video I've done on that, and it talks about the key things you need to know about laws of indices. Write it down, make the key points in your book, and then you can revise it just before you go into the exam. So the next question is to do with laws of indices again, but this time it's slightly different. Now, what you notice is we've got an 8, a 2, and a 2. What I need to basically do is turn all of this so it's base values of 2. Okay. Now, a couple of ways we can do this, but let's just look at what we've got here first of all. Let's tidy this bit up because that's not in a base value of 2 at the moment. So 8 squared to the power of a third. Now, effectively, if I've got 8 squared to the power of a third, I can write it like this. 8 squared being written as 8 with a 2 over 1. And because this is in brackets, I'm going to multiply those together. Okay, which basically becomes 2 times 1 and 3 times 1. So that becomes 8 to the power of 2/3. So I can now work this out because I've just done the laws of indices stuff with the fractions over there. So 8 to the power of 2/3, think about what we just did up here. It's not a negative, so I don't need to flip anything. But 8 to the power of 2/3 becomes the cubed root of 8 and then squared. Okay. Now the cubed root of 8 is 2, because 2 times 2 is 4, 4 times 2 is 8. So that becomes 2, 2 squared is 4. So let's just think about that. We've actually now got this bit I've just worked out here in purple is 4 times 2 to the power of 3 is equal to 2 to the power of x. And again, what I need to do is I need to get this so it's a base value of 2. Well, 4 can be written as 2 squared. So I can write that as 2 squared times 2 to the power of 3 is equal to 2 to the power of what? Well, when you then multiply indices, you just add those two together. So this would become 2 to the power of 5. So x would be equal to 5. Okay? So that's one way of doing it. The other way you could do it is from that first step. 8 squared is actually 64. So I know that 8 squared turns to 64. And then I'm doing 64 to the power of a third. So 64 to the power of a third, same thing. Root, put your 3 on the outside, 64. The cube root of 64 is 4. Okay, so that's another way of doing it. And then the last way you could look at it is 8 squared is 64. And then we're doing 64 to the power of a third. Well, what I'm going to do is now turn this to a value of 2. Well, how many times does 2, if I keep multiplying 2, how many times do I need to multiply it to get to 64? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it's 1, 2, 3, 4, 5, 6. So effectively, I could write 64 as 2 to the power of 6. And then it's to the power of a third. Again, because that's in brackets, I multiply those together. So effectively, I'm doing 6 over 1 times 1 over 3. So it becomes 2 to the power of 6 over 3. And 6 over 3 is the same as 3 goes into 6 twice. So that's 2 to the power of 2, which is the same as 4 anyway. So that's 3 different ways you could look at simplifying that first bit. But ultimately, your goal with this is you want to get it all to a base value of 2. So you need the 2 to be involved in every part of it. Check the video I've done on laws of indices to go into that a little bit more detail, because I've done another example in there to help you out as well. Okay, so looking at question 10 now, which is to do with completing the square. Now, it doesn't actually say complete the square, but because you can see that is then written in that form, that is the format of completing the square. Okay, so again, there's a formula for completing the square, but the way that I like to teach this and the easiest way to remember it is label it A, B, and C. You half your B value. So B is 8 in this case. So it becomes X. Half your B value is, so 8, instead of being 8, becomes 4. So half your B value becomes 4 now. Put it in brackets. Put it in that correct format, so it's all squared. So half your B value, put it in brackets. Whatever you then get here, you square. So 16, and always turn it negative. It doesn't matter if that was negative in itself, you'd still turn it negative. So it becomes minus 16. And then you bring down your C value. C value here is minus 5. And then basically what you do is you tidy this bit up. So it now becomes X plus 4 all squared minus 21. Okay, and that is now in the correct format of that. So Q would be equal to 4. And then R, interesting here, R is already written in the form of minus R. So instead of writing minus 21, I would just write 21. If this was written as plus R here, then I'd have to write minus 21 as my answer. But because it was already written as minus R, okay, I'm just going to keep it as 21. So again, if you're not 100% sure on completing the square, go back, watch the video I've done in the description. But half your B value, put it in brackets, square that number. So 4 times 4 is 16. Always turn it negative, and then bring down your C value. Minus 16 minus 5 becomes minus 21. So we tidy it up. Okay, now, next one here is also to do with completing the square, because it says by completing the square, find the turning point. Now, this is slightly harder, because what we're actually trying to do is find the turning point of something that is not just an x squared, it's now a 2x squared. So what you have to do in this situation here is factorize, first of all. So I factorize out the 2, okay? So instead of it being 2x minus 6x minus 11, I put the 2 on the outside, and it now becomes x squared minus 3x, because I'm effectively just dividing that by 2, and then minus 5.5. Okay, so I've factorised that so that the 2's on the outside. What I'm going to now do is ignore this. So I need to complete the square, for this bit inside the brackets here. So what I'm now going to do is ignore all of this, and I'm just going to complete the square for this. So half my b value, so it becomes x minus 1.5. So I'm halving that b value, put it in brackets, then I square this, so I put my square sign. I square the 1.5, so 1.5 squared is 2.25. And you always turn it negative, so it becomes minus 2.25, and then you bring down your c value, minus 5.5. Okay, now the reason I've added an extra bracket in there is because this is what I'm doing. I'm then completing the square, so doing what I did here inside that bracket, and I'm going to keep that 2 on the outside. So from here, let's tidy that up. So I've still got my 2 on the outside, x minus 1.5 all squared, and then minus 2.25 minus 5.5 is minus 7.75. Close your brackets. Now from here, the last step, which is slightly different to what we normally do, because imagine that that 2 wasn't there, this is in the correct formats for what we did up here. But what I'm now going to do is effectively, imagine I multiply this by this, so I'm just going to leave it factorised like that. And then I'm going to do the 2 times this bit here. So 2 times minus 7.75 becomes minus 15.5. So this is now the correct format for completing the square when the x squared is greater than 1. Then from here, what you finally then need to do is find the turning point. And the turning point, to find the turning point of a quadratic graph, when you complete the square, you change this sign. So change this one. So instead of being minus 1.5, it becomes plus 1.5. And you keep this sign the same. So it becomes minus 15.5. So the turning point on this graph, imagine I had a graph here. The turning point would be 1.5 minus 15.5. So this point down here is where it would start to turn. It would look something like that. Okay, so that's how you would then find the turning point by completing the square. Okay, moving on to question 12. So question 12 is about algebraic fractions. We're going to talk about that. I'm just going to remove this bit here so that then you've got space to see what I'm doing on the next part. Okay, so algebraic fractions coming up next. Okay, so moving on to question 12 here, what we've got is a little bit of algebraic fractions. So as soon as you see this and you see algebraic fractions, what you should be thinking to yourself is factorise. Okay, so if you do that, you're going to be able to then start to simplify things. A couple of things to be aware of. This first bit here, x squared minus 9, is the difference of 2 squares. So if you see an x squared with a negative squared number, so for example minus 25, that factorises to x plus 5, x minus 5. If it was minus 36, it would factorise to x plus 6, x minus 6. Okay, another one to be aware of is if you see something like this, where it's like a 4x squared minus, 49, for example, then in that instance, you've actually got 2 square numbers here. So it goes 2x in both, and then it would be minus 7 and plus 7. Okay, so just be really careful of that. If you see the x squared with a negative square number, it's the difference of 2 squares. So this first fraction here can then simplify. The x squared minus 9 becomes x minus 3, x plus 3, because you square root the 9, and that gives you your 3. The bottom part, what we're looking at is 2 numbers that add to 5 and multiply to give me 6. Okay, so there's not many things that multiply to 6. So the answer is going to be 3 and 2 in this case. So it becomes x plus 3, x plus 2. Because 3 plus 2 gives me 5, 3 times 2 gives me 6. So I've factorised that left-hand bracket. Now I'm going to do exactly the same to this right-hand bracket. This right-hand fraction, sorry. So I've factorised the left-hand fraction. Now I'm going to factorise the right. Let's do the bottom bit first of all, because that's a little bit easier to factorise. So I'm looking for 2 numbers here that add to minus 7 and multiply to minus 14. You won't always have all of these parts being quadratics, but in this instance, everything is going to be factorised into 2 brackets. It could be that one part actually factorises just into 1 bracket in some instances, but because there's quadratics here, it factorizes to 2 brackets. So think to yourself, what multiplies to minus 14? Well, there's not many things that multiply to 14, right? It's 1 times 14 and 2 times 7. So out of those two factor pairs, the only way you can possibly make a minus 5 is by the 2 and the 7. Now, because multiplying here, we're going to get a negative number. One will be positive and one will be negative. So we know it's going to be x and 7 and x and 2. But it's going to be a minus 7 and a plus 2. The reason is because minus 7 plus 2 gives me minus 5. And then minus 7 times 2 gives me minus 14. If you did it the other way around, actually just work it out. So if I did put that as plus 7 minus 2, then that would give me positive 5. So that wouldn't work. So factorise that part. Now, factorising the top here is a little bit harder. The reason it's hard is because there's a 2 at the start of that x squared. So you have to do the a value times the c value. Again, if you're struggling with that, it's worth watching the video I've done on factorising when x squared is greater than 1. And the link will be in the description as well. So 2 times minus 15 is minus 30. So I need two numbers that multiply to give me minus 30, but add to give me minus 1 because that is your minus 1. So one will be positive and one will be negative again. So looking at that, what multiplies to 30? Well, 1 times 30, 2 times 15, 3 times 10, 4 doesn't, and then 5 times 6. Out of those, you've got to think to yourself, how can you possibly get a negative 1? And you have to use the 6 and the 5. So from here, I've got to think to myself, the way to make minus 1 is minus 6 and plus 5. Okay, minus 6 plus 5 is minus 1. Then minus 6 times plus 5 is minus 30. So they're all good. They're the two numbers I'm going to be using. Now here's our shortcut. The 2x that's at the start goes in both brackets. So because this begins with 2x, you put 2x in both parts. We're then going to put the minus 6 in one and the plus 5 in the other. Now this is technically wrong because 2x times 2x would give me 4x squared, and I only needed 2x squared. What you notice is this fraction, this bracket here, sorry, all divides by 2. So 2x minus 6 divided by 2 is x minus 3. So that simplifies, and then this right-hand bracket has to stay the same. So this becomes x minus 3 brackets 2x plus 5. And I put my division sign back in there. Okay. Again, if you need to practice that skill of factorising when x squared is greater than 1, please go back and watch the video on that. It's really important that you understand how to do that skill. From here, I've now got to think about my rules of fraction. So the first thing to think about with algebraic fractions is factorise, because it will help you work out the question. And then the next thing is to think about what you're actually doing. Well, I'm dividing here. So with dividing fractions, we use KFC. So we keep the first one the same. We flip the second one upside down, and we change the sign to a times. So keep the first fraction the same. It becomes x minus 3, x plus 3, over x plus 3, x plus 2. We change it to a times, and then we flip it upside down. So the blue bit now goes to the top, x minus 7, x plus 2, and the red bit now goes to the bottom, x minus 3, and then 2x plus 5. Okay? Now, technically speaking, because we're timesing, what we can actually do is just write all this as 4 brackets. So x minus 3, x plus 3, x minus 7, x plus 2 is the numerator. And then x plus 3, x plus 2, x minus 3, 2x plus 5 is the denominator. And now it's a case of basically looking at what cancels out. So plus 3, x plus 3, x plus 3 cancel out. Because technically doing that means you're just getting 1. X plus 3 divided by x plus 3 is actually just 1. So we can cancel them out. Looking at what else is the same here, I've got an x plus 2 and an x plus 2. So they cancel out. And then I've got an x minus 3 and an x minus 3. So you can see that there's 3 parts that all cancel out, which means my final answer is x minus 7 is left as my numerator, that part there. And then I've got 2x plus 5 as my denominator. So that is my simplified final answer. Okay, so that's your algebraic fractions. Obviously, if it wasn't a division, if it was a addition, it'd be a very different process. But as I say, watch the video for algebraic fractions if you need more practice on that. Okay, next one, question 13. What we're looking at is expanding three sets of brackets. So the way I like to use this is ignore the third one for a minute. We're just going to expand the first two. So moon method here gives me x squared. So x times x, and then x times minus 5 is minus 5x. Then I do 3 times x, which is 3x. And then I do 3 times minus 5, which is minus 15. So expand your first two brackets. Then from there, tidy that up. So now we tidy that up. X squared minus 5x plus 3x is minus 2x, and then minus 15. Okay, so all I've done there is do the first two brackets. That gets you a mark for doing that in the exam. From here, I now bring down that third bracket. And effectively now, what I'm going to do is the moon method, but an additional time. So x squared times 2x is 2x cubed. X squared times 6 is plus 6x squared. Okay. So then I'm going to do minus 2x times by 2x here. This ends up giving me minus 4x squared. Then I'm doing minus 2x times by the 6, which is minus 12x. Okay. Last bit here, I've then got to do this minus 15 multiplied by that 2x, which is minus 30x. And then I've got to do that minus 15 times by the 6 there, which is minus 90. Okay, I've just picked up a second mark there for doing all those 6 terms. And then finally, what you need to do is just collect all your like terms. So 2x cubed, there's no other x cubes, so 2x cubed stays on its own. I've got 6x squared minus 4x squared, which is plus 2x squared. Be really careful with that you collect your terms with negative numbers carefully. Then I've got minus 12x minus 30x, so it's minus 12 degrees. It gets 30 degrees colder, so that's minus 42x. And then there's no other numbers, so minus 90. That would be your third and final mark. Just if you do it like this and you start with each part, multiply, 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 it just makes it really easy for you to then collect all your like terms. Okay, 3 marks. Just really be careful and go back and double check yourself on a couple of the bits there because it's easy to make silly mistakes. Okay, next one, moving on to a bit of probability. So the probability of me winning a game of badminton and a game of tennis are shown below. What we're assuming here as well is that the games are not linked, so the probabilities don't affect each other. So the probability that I win the game of tennis and badminton are here. Badminton, first of all, 8 out of 10, so therefore the probability I don't win is 2 out of 10. Okay. With tennis, it's 1 over 5, so the probability I don't win is 4 over 5. Probability of winning again will be 1 over 5 and 4 over 5. So complete probability tree, just making sure that you know that they have to add up to 1. It should be relatively simple for you. You should be quite confident with that. So what we're now going to do is look at this second part to the question, which is a little bit harder. So it says, work out the probability of me winning at least one game. So where it says at least one game, I need to think about all my possible routes. So to at least one game means I could win, then I could win. I could win, and then I could not win. Okay, so not win. I could not win, and then win. So basically, I'm saying I could go win badminton, win tennis. That's at least one win. Win badminton, don't win tennis. I've still got at least one win. I could not win badminton, but win tennis. The only one I can't take is this one here. So I can follow that path, and this path here. So what you need to do is, the way I like to do this is to just circle the routes you could take. We're going to call that route 1. Second route I could take is win and don't win. That's route 2. And then the third one would be don't win and win. That's route 3. What you need to remember is whenever you are following a path or you're following a route, you need to multiply the fractions together. So for route 1, you're doing 8 over 10 times 1 over 5, which gives you 8 over 15. Okay. Route 2, you're doing 8 over 10, and we're timesing by 4 over 5. So that gives you 32 over 50. And then the last one, route 3, we're doing 2 over 10 times 1 over 5, which is 2 over 50. Okay? So they are all my possible routes I could go, the probability of me winning at least one game. If you have multiple routes that you can follow, what you then have to do with your answers is add them all together. So I'm actually saying 8 over 50 is my route 1 plus 32 over 50, which is my route 2, plus 2 over 50, which is my route 3. So if you've got multiple routes to follow, add them all together. When you are adding fractions, your denominators need to be the same. So we're all good here. My denominators are the same. And then, very simply, the probability here would be 42 out of 50. Okay, so the probability of me winning at least one of those games is 42 out of 50. If you wanted to put that as a decimal, you would obviously double it. So that becomes 84 over 100, which is 0.84. Or you could put it as 84%, depending on what the question's asking you to do. But leaving it as a fraction as 42 over 50 is fine as well. The other way you could answer this question is you could actually think about, well, what route can I not take? So if we did it the opposite way around here, and I started thinking about routes I can't take, this is the only route I can't take. So you could say 2 over 10 times 4 over 5, which is 8 over 50. So that's the route I can't take. So therefore, what you would do is instead of adding that to the other ones, you would then say, well, 50 over 50 as a whole. You could then take away 8 over 50 because that's the route you can't take to get 42 over 50, which would be my answer for me winning at least one game as well. Okay, so that's a bit of probability. Probability trees, just remember whenever you're following a path, whenever you're following a route, you multiply. And then if you've got multiple routes you can follow, you have to add them together. Okay. Okay, so moving on now, question 15, we're looking at some bearing work. So it says here, the bearing of B from A. The thing that confuses pupils is the wording of this. So think about what this means. So it's the bearing of B from A. So when it says from A, that's your starting point. Okay, so if we sketch this out, if we had a look at this, this is A. The bearing of B from A is 0.65. So we're going to add in a north line. So the first thing to do is think about adding in a north line. 0.65, you would then measure 65 degrees round, which would probably be somewhere around here. And you're going to draw a line to B. So what I'm saying is this angle here is 65 degrees. So the bearing of B from A, so this is where I'm starting, and I'm going in that direction to B, okay, is 0.65. A couple of key things to remember about bearings is they always start from north, they always go clockwise, and they always have 3 digits. Really important that you remember those key things. So start from north, always go clockwise, 3 digits. So in this case, starting from north, 0.65 is that way. That's why I put a 0 in front of it, because it's 0.65, not just 65. And then I end up at B. So this is my sketch that might help me work this question out. I'm going to draw my north line in for B there. So these two north lines are parallel. It's really important you understand that. What it's now saying is find the bearing of A from B. So now I'm here. Now I'm standing at B because I'm coming from B to A. And I'm going this way. You can't just reverse it. What you have to do is think back to these key things we said here. You've got to start from north and you've got to go clockwise. And it has to be 3 digits. So what I've actually got to find is this whole shaded bit here that I've just done. And in order to do that, what you need to understand is that this angle here and this angle here are co-interior. Okay, so that shape there, if I was to go back to my rules of parallel lines, that's my C shape, which means this angle here and this angle here both have to add to 180 degrees. So what you're actually saying is 180 minus 65, which is 115 degrees. This angle here is 115 degrees. Okay, the reason is because within parallel lines, co-interior angles have to add to 180, and by doing that, you end up getting that 115. From here then, hopefully you can see what happens. The whole thing has to add up to 360. So therefore you're doing 360 minus 115. And when you do that, that will give you the bearing of A from B, which is 245 degrees. Okay, so that whole bearing is 245. It's from north, it's clockwise, and it's 3 digits. Okay, the key thing to that is read the wording. When it says from B or from A, that is where you are starting. Okay, right, next one, question 16. Enlarge shape A by a scale factor -2. So this is a negative scale factor. Okay, negative scale factors flip the shape and also make it bigger. So it's really important. This only comes up in higher, doesn't come up in foundation at all. So whenever you've got a negative scale factor, it will flip the shape upside down. And it tells you the centre is 1 minus 1. So let's first of all assume, I should have put the scale one here, but let's just assume each one of these squares is 1. Okay, and then so -1, -2, -3, -1, -2, -3. So if I then plot first of all my centre, 1 minus 1, that's my centre of enlargement. That's where I'm actually going to enlarge this shape from. And with negative enlargement, here is the best way I've found to do this. Let's pick a point on shape A. I'm going to draw a line across and go through the centre. So with negative enlargement, you go through the centre of enlargement. So negative enlargement, we go through the centre of enlargement. Now, from here to here is 1, 2, 3, 4 squares right. So I go 4 right. Because my scale factor is -2, the minus part tells me I'm going to go through the centre of enlargement. The 2 is how many times I need to times it by. So I'm going to times that by 2 now, and I'm actually going to go 8 right. But this time, I'm going to start at my centre of enlargement. So I now go 1, 2, 3, 4, 5, 6, 7, 8. And this will be my point that I am working at now for that purple point. So that there is going to be my new top point of A. Let's choose another point, this bottom right. So I'm going to go through again. I'm going to draw a line, just go straight through that centre. Okay, so it goes through the centre of enlargement, and I'm keeping it. You can see there that it's really clear that that goes through the corner, through the corner, through the corner, all the way through and out the other side. This one's a little bit harder because I've got to go 1, 2, 3 right. So right, 3 right. And then I go 1, 2, 3 right, 1, 2, 3 up. So 3 right and 3 up. My scale factor is 2 again, so I times that by 2. I'm going to go 6 right and 6 up. Remember, you go back to your centre of enlargement and you count 6 right, 1, 2, 3, 4, 5, 6 right, and then 6 up, 1, 2, 3, 4, 5, 6, and you can see I end up on that line there. So that bottom right hand corner of the triangle now actually becomes that point there. Final one, pick that point, draw my line straight through the centre again. So you're making sure that it's as neat and tidy as you can get it and as tight to that point. Same thing from here, 1, 2, 3, 4, 5 right I go now. So 5 right, and it's still 3 up because obviously it's in the same place. 1, 2, 3, 4, 5, 1, 2, 3, times that by 2. So I go 10 right and 6 up. Go back to your centre of enlargement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right. 1, 2, 3, 4, 5, 6 up. And you can see I end up getting to that point there. Okay, then it really simply, it's a case of you joining all your points together. It might tell you to label it B, and that is my new shape. You can see it's flipped the shape upside down, and it has also got bigger as well. Okay, again, if you need a little bit more practice on negative enlargement or just to recap it in a bit more detail, click on the link in the description for question 16, and that will help you a little bit more. Okay, so moving on to question 17, we're going to look at exact values of trig. So what I've got here is a diagram of a hand, which is going to help you with exact values of trig. So I'm going to quickly just recap this. So what you need to do is label it first of all. So imagine you put your left hand up you need to label each one of those fingers 0, 30, 45, 60, and 90 degrees. Okay, these are the only numbers you'll be asked about with exact values of trig. This is fairly easy to remember because if you think about it like this, that's your right angle, then your 45 degrees just sits in the middle there. So then you need to kind of just remember the 30 and the 60 of those two. Okay, so that's just quite a nice, easy way to remember it. Now, next thing to remember is when you're asked about sin, okay, to find the value of sin, it's the square root of however many fingers you have below the number over 2, okay? Let me give you an example. So if it was sin 30, you put this finger down. So effectively, what you're doing is getting rid of this finger. So sin 30, we're getting rid of that. Then you're saying how many fingers are below. Well, in this case, there's 1, because there's 1 finger below what we're doing. So that's root 1, and then it's over 2. Well, the square root of 1 is 1, so it's just a half. Okay, let me give you another example. So let's get that back. If I said to you sin 60, so if we did sin 60, you will go to this, put down this finger, because that's the 60 degrees. You're looking at how many fingers are below. Well, there's 1, 2, 3 fingers below. So that's root 3 over 2. And you can't simplify that at all, right? Whereas this one, square root of 1 is 1, you can work it out. Root 3 over 2, you can't simplify. So what you need to do is just remember that for sin, it's the square root of the fingers below over 2. The way to remember that is when you sin, it's a bad thing, so it goes down. Okay. Next thing to think about is what happens with cos. So if we've got cos, it's the opposite of that. So it's the number of fingers above over 2. So in this case, let's look at an example. Let's do cos 30. Well, you would put down this one. So how many fingers do you have above in this case? 1, 2, 3. So therefore, cos 30 is root 3 over 2. Again, you can't simplify that. Let's do another example. If I said to you cos 60, so again, cos 60, we put this finger down. How many fingers do you have above? Well, there's 1 finger above, so that's the square root of 1, always over 2, which is a half. Okay, so cos is the opposite of sin. It's root above over 2. And then the hardest one to remember is tan. Tan is a combination of those two. It's the square root of the fingers below over the fingers above. Okay, so let me give you an example. Let's do tan 30. So if I go to tan 30, I would put this finger down. So that finger goes down. How many fingers do I have below? Well, it's 1. So you're saying root 1 over, how many fingers do I have above? 1, 2, 3, root 3. So root 1 over root 3, square root of 1 is 1, so it's actually 1 over root 3. But then what you also need to think about is that you cannot have a surd at the bottom, so you need to rationalise that. When I rationalise it, you times it by the root 3, so that just becomes root 3 over root 3 times root 3, which is root 9, which is that. So tan 30 is root 3 over 3. Okay, so definitely worth getting your head around those key things I've written there in the bubbles, and making sure that you understand what to do and how to solve these kind of problems. So let's look at it now. So it says, work out the value of sin 60 times tan 60. So first of all, sin 60. So sin 60, we're putting this finger down. How many fingers are below? 1, 2, 3. Because with sin, you go below. So it's root 3, always over 2. Okay, so I put this finger down, 1, 2, 3 below, over 2. Then I'm going to do tan 60. So tan 60, 60's gone down. How many fingers below? Root 3. So tan is root below over root above. There's a 1 above. So it's root 3 over root 1. Pretty simple here. That just becomes root 3 over 1 because the square root of 1 is 1. So we can say that sin 60 is root 3 over 2. Done that. And we're timesing by tan 60, which we're saying is root 3 over 1. And then therefore, because you've got two fractions, you just times the top and times the bottom. So when you're working with fractions and you're multiplying, top times top, bottom times bottom. Root 3 times root 3 is root 9. 2 times 1 is 2. The square root of 9 is 3. So 3 over 2 would be your answer. It then says here, give your answer as a mixed number. So how many times is 2 going to 3? It's once, with 1 left over. Okay, so that would be your answer there. Key thing to remember here are these values here. The exact values of trig, definitely worth getting your head around and remembering that trick with your hand. So I always use the left hand, probably because I'm right-handed. So you just hold that left hand out, put down the finger that you're looking at, and just remember sin is root below over 2, cos is root above over 2, and tan is root below over root above. And then just remember with tan, if you end up having a surd at the bottom, you just need to rationalise. Okay, question 18, we're going to start looking at some more complicated stuff now, where we're looking at equations of circles, and we're looking at tangent lines. Okay, so looking at this then, if we were to sketch it out and visualise what it looks like, the circle would look like this, and I'll talk to you about that in a little bit more detail in a second. But that's approximately, if we just go for a quick approximation, what our graph would look like. We know what we've got is the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. That's that point there. And we've got a tangent line that is doing this. Okay. What it's asking you to do is find the equation of that line there. So we'll label that tangent. Okay. So from here, what we need to start thinking about is tangent lines are going to be perpendicular lines. So what I need to do is try and find the perpendicular to this. So the perpendicular to this tangent line would be this line here. So what I now need to do is find the equation of the red line. So let's call that the first line. Now that first line is actually going to be my radius. Because if I get rid of the last bit of this line here, and I just keep the first part of that line, you can very clearly see that that is the radius of the circle. Now, how do you find the gradient of a line? So again, you need to make sure you're happy with gradients of lines. It's change in y divided by change in x. And I can see here that my change in y is this part here. So 1, 2, 3, 4. And my change in x is the base there, which is 3. So 4 over 3. This red line has the equation y equals 4 over 3 x. And remember here you need the y-intercept, as we spoke about previously. The y-intercept is 0. So the equation of this red line, the first line, is y equals 4 over 3x. Or you could call that 1.3 reoccurring, but we can just leave it as 4 over 3x. So perpendicular lines, the first thing you have to try and find is the reciprocal. Okay, so the reciprocal, we're still going to be looking at y equals mx plus c. So I need this format, but to get that format, what I'm going to say is y equals, I take the reciprocal of this, and the reciprocal of that, we flip it upside down, so 3 over 4x. But because this one here is a positive, this one becomes a negative. Okay, and I don't know c. I don't know this point here where it passes through. That's what I need to find now. So we've then got our reciprocal gradient. So we picked up a mark probably for finding the equation of the first line, the gradient of the first line. I found my second mark here for finding the reciprocal. Could be 1 mark, could be 2 marks, depending on the question. So anytime you see a tangent and a circle, try and find your gradient of one of the lines, find the gradient of the radius first, or and then using that, you can use a reciprocal to find the equation of the tangent. So now I've got that, what I know is it goes through these points. So I'm saying, so we've got 3, 4, that's your x value, that's your y value. So what I do is I take those values and substitute them into the equation. So we're saying now y is 4, so I change y for 4, is equal to minus 3/4 of x, and we know x is 3, so times x, which is 3, plus c. The reason is because that means minus 3/4 times by x. So minus 3 over 4 times by 3 plus c. Now I'm going to keep all this as fractions to make this easier. I'm going to zoom in a bit. So keeping this all as fractions, it makes it a lot easier. When you're multiplying with fractions, you just multiply top by top, bottom by bottom. So therefore this becomes 4 is equal to minus 9 over 4 plus c. Okay, so I've got this as my process so far. I need to get c on its own, so I'm trying to find the value of c. So I take this over the other side and I say 4 plus 9 over 4 is equal to c. Now 9 over 4 you could actually simplify. You could say that's 2.25 if you wanted to. You could keep that as a fraction, or you could turn it to 2.25. The reason I know it's 2.25 is because 4 goes into 9 twice with 1 left over. So that's 2.25. Or you could keep it all as fractions if you wanted to work in that way as well. So therefore c is equal to 6.25. So now I've got c as 6.25. I go back to my initial equation. So let's just rub this out for a second. My initial equation being this one here. And I say y is equal to minus 3/4 of x and then plus 6.25. Let's look at my diagram over here. This point here looks like it would be around about 6.25. So that's perfect. It kind of works with the scale we're talking about. Okay, so that's how you can use perpendicular lines. If you're not 100% sure, it's a difficult topic. It will come up towards the end of the paper. If you're not 100% sure, watch the video in the link in the description that I've done on perpendicular lines. Okay, moving on to the last couple of questions. So we're going to talk about histograms here. So the table below shows money spent by 250 people at a rugby game. Okay, so histogram. First thing you need to think about is frequency density. Okay, really important that you think about frequency density as soon as you see a histogram. And frequency density is frequency divided by the class width. Now what I mean by that is this is your frequency, 50, and your class width is a difference here. So the class width here is 50, class width here is 25, class width here is 25, class width here is 30. Okay, so with a histogram, what you need to do is add on that second column, so frequency density. Okay, so let's work this out then. 50 is my frequency divided by the class width, which is 50. So my frequency density for this is 1. Next one, 75 divided by my class width, which is the difference between 50 and 75, which is 25. So my frequency density becomes 3. Okay, you might want to pause the video and have a go at doing the rest of these yourself if you haven't done it already. The next one, 100 divided by class width, which is 25. So that gives me 4. 15 is my frequency divided by 30. Be really careful here. It might be easier for you to put these as fractions. So 15 over 30, which actually simplifies to a half. So 0.5. So just be really careful with that one that you don't accidentally put that as 2 and do 30 divided by 15 because that gives you 2. Make sure you're doing 15 divided by 30. Think about it like this. You're on this column, so you work backwards. That one divided by that. Okay. And then the last one, 10 divided by the difference between those two, which is 20. Same thing. It's not 20 divided by 10. It's 10 divided by 20, which is a half, so 0.5 as well. Okay. So we worked out our frequency densities, which is 1, 3, 4, 0.5, 0.5. So on your histogram, we need to label this y-axis as frequency density. Okay. You might be asked in an exam, explain a misconception, explain a mistake, as in what's gone wrong. It could be that that y-axis is actually just a frequency. So a really common mistake for pupils with histograms is they plot frequency along here. It's not a bar chart. You must make sure you find frequency density. So let's look at the x-axis as well, which is going to be amount. Okay, so that's amount, and we can put it in pounds. Now, looking at this, we're going from 0, so 0 there, we need to go up to 150 as our total value. So I think looking at that, it looks like each one's going to be 10, 30, 40, 50. So you might have to fill in the scale yourself. You might be given the scale. It's depending on what the question will say. So then look at the frequency density. Our highest number here is 4. So I need to be able to go up to 4. So I could go 1, 2, 3, 4. Perfect. So each one of those lines there is 0.5. Okay. So plotting this, I'm just going to make it a little bit bolder so you can see. The first one has to go from 0 to 50 and to 1. So you're plotting the width against the frequency density. So 0 to 50, I go up to 1. So my first bar would look like this. Okay. My second bar, 50 to 75, so a little bit of a shorter bar, and I'm going up to 3. So that's 75 down there. So you can see that my bottom goes from 50 to 75 because that's the group, and I've gone up to 3 because that's my frequency density. 75 to 100, so 75 to 100, and I'm going up to 4 this time, so this is going to be my biggest bar. So up to 4, and that's going to 100. Draw my line down, done that, perfect. Next bar is going to be 100 to 130, and that's going to be at 0.5, so a bit of a smaller one. So 100 to 130, 0.5, and then my last bar, 130 to 150, you can see, is also at 0.5. What an examiner is looking for is that you've got bars of different widths, which you can clearly see here, differing widths, and that you've plotted it against the frequency density, not against the frequency. Okay, so that's plotting a histogram. It then says estimate the median amount of money spent. So this is where histograms become a little bit harder. Okay, so let's just think about what we know. We know that there are 250 people. So 250 people. And I'm being asked to find the median. Okay, so the median is the middle. It's the middle value. Now, out of 250 people, this is an estimate. So divide that by 2, you're talking about 125. I need to find the 125th person in this histogram, okay? Because the median is the middle, 250 people, divide that by 2 is 125. So what I need to do is I need to think about how many pieces of data are in each bar. So looking at the first bar, we know that that is a total of 50 people. In the second bar, I know that that is 75 people, okay? So if I was to just accumulate all of this, I've got 50 people there, add on another 75 people, and you can really easily then see that at this point here, 50 plus 75 is 125. So the 125th person sits smack bang down there. So the median amount of money would be £75, okay? Now, sometimes it might not be that simple, okay? So the median might not fit perfectly on that bar there, okay? So it might ask you for something like the upper quartile, okay? So let's talk about the upper quartile, or it might ask you for the lower quartile. So the upper quartile would be 3/4 of the data. So to find 3/4 of 250, you would divide it by 4. And then once you've done that, you have to times your answer by 3. So 250 divided by 4 would be 62.5. And then times that by 3. So at that point when you do that, so you're doing 250 divided by 4 to get 62.5, and then you're timesing that answer by 3, because if we were talking about upper quartile, that gives you 187.5, right? So what you're actually looking for is the 187th piece of data, 187, 188, because it would be an estimate. So this is only if it was asking for something like the upper quartile or the lower quartile. So I'm just doing an example of upper quartile. So at that point, we're saying that's 50 people, that's 75 people, so in total I'm 125. Now in this next bar, between 75 and 100, so 75 and 100, there are 100 people in here. So this bar is 100 people. So what we can actually do is we could split this bar down the middle, because at this point here, that's 225 people. I'm looking for the 187th person. So let's just zoom in a bit here so you can see. If I split it down the middle, I could say there's 50 people there and 50 people there. So if that's 125, then this here would be the 100. Let's just rub that out. So at this point here, adding on 50 to 125, that's the 175th person. Remember, I'm trying to aim for 187. So if I then split this again down the middle, there would be 25 there and 25 there. So at this point, I can say that's the 200th person. What I can now do is again split this in the middle. So go down here, and I could say that in here there'd be 12.5 people, in here there'd be 12.5 people. So 175 add on 12.5 gives you 187.5, which means that this line here that I've got, this purple line, would be the 187.5 person, which you can see would be £90. So your upper quartile would be £90. So that concept's a little bit harder to get your head around, but if you start splitting the bars into separate sections, then it will help you work it out from there. Okay, so that would be how you can find median. So the question was actually about median. I've just explained if it was asking for upper quartile or lower quartile, that's how you could work it out. Okay, so last question then, we're looking at vectors. So key thing to think about with vectors is that whenever we're talking about vectors, we're talking about just basically paths that you can follow. If you think about vectors like paths or roads, you can only travel along a path if you know the name. So for example, if I'm at A and I want to get to B, it tells me A to B is lowercase a. It gives me the arrow. So for me to go from A to B, the name of this road is A. For me to go from A to C, the name of this road is 2B. It tells me that A to D is 2 lots of B to C. So what I'd suggest you do is with vector questions is you don't necessarily just read the whole thing all in one go. What you could do is just work out bits. So on this, I can see straight away that I don't have this road here. This road name is missing. So B to C is missing. So how would I go from B to C? So if I'm standing here at B and I want to get to C, this road's shut. So I've got to go this way, then this way. Okay, so I'd go B to A and then plus A to C. Now, thinking about that, B to A, if I'm going against this arrow, it becomes minus A. And then A to C is plus 2B. Okay, the reason that's plus 2B is because I'm just following the same direction as it. So therefore, I could write B to C as 2B minus A or minus A plus 2B. What I'm then going to do on my diagram, I'm actually going to write that on. So I'm going to write 2B minus A. So that is the name of BC. Now you might need it, you might not need it. Okay, but what I'd suggest you do is whenever you've got missing roads or missing lines in a vector question, just figure them out, work out what they're called. Okay, now I can use this piece of information because it tells me A to D is 2 lots of that. So I need to then work out 2B minus A, and I've got to do 2 lots of that. So I'm times in by 2, which means it becomes 4B minus 2A. So this whole line is 4B minus 2A. Okay, so the entire A to D is 4B minus 2A. So let's read the rest of the question. It says X is the point on AD that it splits A to X and X to D in the ratio of 5 to 3. So let's think about roughly where that would be. So it'd probably be somewhere about there. Okay, so it says 5 parts to 3 parts. Okay, and this is where you start to involve ratio and fractions into this. So if you imagine this entire line along here, I need to split it into a total of 8 parts. Okay, so 1, 2, 3, 4, 5. So that's where X is. And then 1, 2, 3. So you can think about it a bit like boxes. However you work with ratio, you can just write that out. So that's 5, and that's my 3. Now what I'd suggest you do is with vectors, whenever you get a ratio involved in it, turn them into a fraction straight away. So where it's 5 to 3, we're going to call that 5 over 8 because it's a total of 8 parts, and 3 over 8. Okay, so a to x. So for me to go from a to x is going to be 1, 2, 3, 4, 5 parts of that line. Okay, so it's 5 out of the 8 parts of the entire line, and the entire line is 4b minus 2a. If I wanted to go x to d, well, x to d is going to be 3/8, because now I'm going from here to here, which is 3 parts, 3/8 of that whole line, which is 4b minus 2a. Now, there's a couple of ways you could actually write that as well. You could leave it just like that, or what you could do is you could expand it out. So what I'm saying is 5 over 8 times 4, 4b, and then I'm saying 5 over 8 times minus 2 as well. Okay, so you could write it out in full, and then that would give you 20, because when you're multiplying fractions, remember we just put those over 1. Multiplying fractions, you just times the top by the top. So it becomes 20 over 8b minus, so 5 times minus 2 is minus 10, minus 10 over 8a. Okay, or you could also write that, how many times does 8 go into 20? Well, that's 2 with 4 left over, so that'd be 4 out of 8, which is 2.5b. And then 8 goes into 10 once with 2 left over, so you can say once with 2 out of 8 left over, which is 1.25. Okay, or you could call it 1 1/4 of a. Okay, so you could write it like that, or you could leave it factorized. I would say it's probably better to write it like this, because then we're going to need to do some collecting of like terms. The question is now finally asking me to find b to x. So how do I start from b and get to this point x? There's a couple of ways you could go, okay? You could go a long way. You could go here, here, and here in a little Z shape, or we could go this way and this way. And we're going to do both, so I can show you that they both give you the same answers when you do it. So I'm just going to move all that to the side, make it a bit smaller. So for me to go from b to x, which is ultimately what I'm trying to do, I have to go b to a plus a to x. Okay? Well, we know b to a is minus a, and we know a to x, we've just written it all here. That was my a to x. So it's plus 2.5b, and then minus 1 1/4 a. So now what I'm going to do is tidy all of that up. Okay, I've got like terms here. So minus a minus 1 1/4 a, that's the same as having minus 1a. So it's minus 2 1/4 a, and there's no other b's, so plus 2.5b. So what you could then do technically on this diagram, you could draw a new line now. You could go, for me to go from b to x, that's my arrow, I'm going in that direction, and you could say it's 2 1/4 of a plus 2.5b. Okay, so that would be one way of doing it. That's by far the easiest way. You're just following paths you know. Remember, this would be one of the last questions in the paper, so it is getting complicated at this point. So the last way I'm just going to show you is that if I do it a different way, you'd get the same answer. So if I wanted to go b to x, what I'm now going to do is go this way, and this way. So b to c plus c to a plus a to x. They are my 3 bits I'm taking. So b to c we know is 2b minus a. So that's b to c, that bit there. C to a is minus 2b, because I'm going against the line. And then we know a to x is exactly the same as what we've got anyway, which is is this bit here, a to x, or this bit here. So plus 2.5b minus 1 1/4 a. Okay, so if we then look at that, what I'm saying is when I tidy all that up, I should end up with the same as what I've got there. So let's see what happens. So collecting like terms, I've got 2b minus 2b, so they cancel out. Minus a minus 1 1/4 a is exactly the same as what I had up here. So that gives me minus 2 1/4 a. And then there's no other b's involved, so plus 2.5b. So you can see that when I follow that route that I've just done, I end up with exactly the same answer as I got there. You could also write that as 2.5b minus 2.25a if you want to keep it a bit tidier, a bit neater, because you've got the negative part coming second. Okay. Obviously, vector questions can become a little bit more complicated. They might ask you to find a particular part or prove that lines are collinear or parallel. So it might be worth doing some more research into vector questions, but these are the basics that you need to get your head around and understand. Okay, right, so we've gone through 20 different topics there. So if I just quickly jump back to the start, we've gone through 20 different topics there. These are the things we've gone through. I suggest you go back and make sure you spend some time revising the ones that you are not 100% sure on, and get yourself prepared for that paper 1 coming up. Okay, hope you found it useful. Hope it helped you. See you guys in the next video.